Hi students, in this video we will discuss one more topic. Already we have discussed the two chapters as per 2023 and 24 blueprint. According to that, we are discussing, we are making these videos. And in first chapter, we have one MCQ question for annual examination. That topic is discussed, and second chapter is not there for annual examination. So that we are not discussed about that MCQs. And third chapter is current electricity is there, and in second video it is discussed. Now we move on to the fourth chapter, that is moving charges and magnetism. This chapter is also having MCQ question for annual examination and also for midterm examination directly, so that we move on to the topic on MCQs. Okay, these are the most expected questions we are discussing. Okay, now move on to the video. Right. Okay, first question. Now we start to the first question. Okay, here it is there. Okay, now we go for first question. A charged particle enters in a magnetic field perpendicular to the magnetic lines of force. Okay, magnetic field or magnetic lines of force. Okay, now what they are asking, the path of the particle is what? Now say in theory class we are discussed a charged particles enters a magnetic field that is perpendicular to the magnetic lines of force means no doubt it is a circular path, right? Okay, first option is straight line is there, second option is circular is there, and fourth C option is ellipse, and D option is spiral. So the right answer is B option here, right? Okay, right answer is this one. This is the answer. Okay, now we move on to the second question. Right. Okay, second question. Now see what they are asking in second question. A charged particles enters at 45-degree to the magnetic field. Its path becomes. Now see exactly at 0 and 180, that is the different case, and 0 to 90-degree. Okay, what happens when a charged particles are entering into the magnetic field? Now in this case what they are given, 45 is given. You remember 0 to 90-degree up to 189, sorry, up to 89. What will happen when it enters into the magnetic field means that the charged particles will takes the helical path. So the okay, now options will discuss. First is circular is there, not like, and helical is there. This is the right answer. And C is elliptical is there, and D is spiral is there, right? Okay, you remember when a charged particles are entering into the magnetic field uh, from greater than 0 to less than 90, whatever the angle, either it is 35, 40, 45, 50, 60, whatever, okay, and greater than 0 and less than 90-degree means the charged particles will takes the helical path. So the option is B is the right answer. Okay, now we move on to the next question, third question. Now see in third question what they are asking, the path of a charged particle moving along or opposite to uniform electric field. Okay, now see the path of a charged particle is moving along means theta equal to 0 and opposite means theta equal to 180-degree. Means when a charged particles are entering along the direction of uniform magnetic field or opposite to the magnetic field, now what will happen? Okay, what will happen means a straight path will be produced. So the option here, now see, first A is circular is there, B is straight path is there, C is helical is there, and D is spiral is there. Okay, when a charged particles are moving parallel or opposite or anti-parallel to the electric field means straight path will be produced, right? Okay, now see what is next question is when will be the magnetic force on a moving charge can be maximum in a magnetic field? Okay, in theory class we are studied magnetic force will be maximum when theta equal to 90-degree and theta equal to 0 means the magnetic force will be minimum or 0. Okay, now we see discuss when will be the when will the magnetic force on moving charge can be maximum in a magnetic field means theta equal to 90-degree means it is maximum. So the option A is a right answer. Theta equal to 45, no. Theta equal to 0 means it is minimum case it is. And theta equal to 180, this is also minimum. So the option A is the right answer. Okay, now move on to the fifth question. When will be the magnetic force on a moving charge be minimum in a magnetic field? Now, just only we discuss, if theta equal to 0 means magnetic force will be minimum. So the option C is the right answer. Now move on to the sixth question. What happens to the current carrying conductor placed in a uniform magnetic field? Okay, you remember when a current carrying conductor placed in a uniform magnetic field means it experiences a torque. It experiences a torque. Okay, you remember only it experiences a torque, right? Okay, now see we'll see the options. It experiences electric force. No. It experiences a torque. Yes. It experiences a torque. It experiences a magnetic force. All the above. So when a current carrying conductor placed in a magnetic field means it experiences a it experience a sorry. Oh, sorry. This option is C option is the right answer here, because what happens to current carrying conductor placed in uniform magnetic field means if current carrying conductor placed in uniform magnetic field means magnetic force will be experienced, right? If suppose current carrying loop is placed in a magnetic field means torque will be experienced. This is not a loop, it is a conductor. Okay, it is placed in uniform magnetic field means it experiences magnetic force, right? Okay, seventh question. SI unit of current element. No doubt, this is very simple. SI unit of current element is ampere meter, because current element means current is there, some length will be there. Okay, small elemental length. Current having small elemental length. Current means SI unit of current is ampere, and length means it is measured in terms of meters. So the ampere meter is the SI unit of current element. So the options are A is ampere per meter is there, wrong. B is ampere per meter square is there, wrong. C is coulomb meter is there. This is also wrong. And D option is ampere meter is there. This is the right answer. Right. Next, the SI unit of magnetic dipole moment. What is magnetic dipole moment? Magnetic dipole moment is denoted as P. P equal to, so, product of current into area element. Okay, what is magnetic dipole moment? Magnetic dipole moment is the product of current into area element. I into A. Current can be measured in terms of ampere and area means meter square. So, SI unit of magnetic dipole moment is ampere meter square. Okay, first option is ampere meter is there. No, wrong. Ampere meter square is there. This is the right answer. Ampere per meter square, ampere per meter square. Okay, these are the wrong options, and B is the right answer. Okay, now ninth question. What happens to the current loop? Now this is the question. No, similar question we are discussed in previous case. What happens to the current loop when it is placed in a uniform magnetic field? What will happen? It experiences a torque. Oh, current loop is there. Loop is placed in magnetic field means it experiences a torque instead of force, right? Okay, so the option B is the right answer. First option is it experiences a force. No, it experiences a torque. A and B, no. D, none. Okay, so the option is B is the right answer. Okay, now 10th question. Question number 10. A current carrying wire produces only electric field, only magnetic field, both electric field and magnetic field, and no field. Now say a current carrying wire produces, what will it will produces? It will produces magnetic field around it. So the option B is a right answer, because current carrying wire produces magnetic field around it. So the option B is a right answer. Okay, now see this type of problem means one formula is there, and here one question will be arises, right? We will discuss. A charged particle of mass m is there and charge q is there. Describes a circular motion of radius r in a uniform magnetic field of strength b. The frequency of revolution is okay. Frequency f equal to qb divided by 2 pi m. So the option A is the right answer, because frequency of revolution f equal to or nu equal to qb divided by 2 pi m is there. This is the right answer. A is the right answer, because qb divided by 2 pi rm is there. Radius will not comes. 2 pi m divided by qb is there. No. Bm divided by 2 pi q is there. So the option A is the right answer. Okay, now see in option, frequency of a charged particle moving in a uniform magnetic field is directly proportional to q. Means q means charge. and directly proportional to B, magnetic field, and inversely proportional to mass, right? You remember this formula, right? Okay, next we'll discuss 12th. The magnetic field inside a solenoid. Okay, we have expression for magnetic field B equal to mu naught N I is there. Mu naught N I is there. Okay, now see, means magnetic field inside a solenoid is directly proportional to mu naught number of turns and current. Now see, we'll discuss. Directly proportional to its length? No. Directly proportional to its current? Yes. Inversely proportional to number of terms? No, because directly proportional to number of turns. Inversely proportional to current? No. So the option B is the right answer. Directly proportional to its current, because B equal to mu naught N I. B is directly proportional to I. Right? So the option is B. B is the right answer. 13th. Okay, now we'll discuss 13th. A moving coil galvanometer can be converted into ammeter by connecting. Okay, we are measuring current means we are making current. A high resistance in series, a high resistance in parallel. No, in case of ammeter, a low resistance in parallel. A low resistance in parallel. So the option D is the right answer. A moving coil galvanometer can be converted into ammeter by connecting low resistance. Low resistance is called as what? Shunt resistance. That is connected in parallel. So the option D is the right answer here. Right? Okay, similar question is there. A moving coil galvanometer can be converted into voltmeter by connecting high resistance in series. We know already a moving coil galvanometer can be converted into voltmeter by connecting a high resistance in series with it, right? So the option A is the right answer. No, no. 15th, question number 15. The resistance of an ideal ammeter is 0 because no resistance is 0. So the option D is the right answer. The resist. Okay, now the 16th question. What is the work done by magnetic field on a charged particle? No, no work done is 0. Why? Because in okay, what will happen in case of magnetic field? Both electric field and magnetic field will be produced simultaneously. In work done will be 0, right? So the option D is the right answer. In the resistance of an ideal voltmeter, okay, voltage we are measuring means we need high resistance. How much high? Infinite resistance, right? Okay, resistance of an ideal voltmeter is infinite. So the option C is the right answer. Okay, now see 18th question. In a moving coil galvanometer, a current I produces deflection theta. Then, okay, we know in case of moving coil galvanometer, deflection produced in the galvanometer is directly proportional to the current in the galvanometer, right? Means I is directly proportional to theta. Okay, now see first option is A. I is directly proportional to tan theta. No. I is directly proportional to theta. Yes, this is the answer. Answer B is the right answer. I is directly proportional to theta square. I is directly proportional to theta cube. No, option B is the right answer because deflection produced in the moving coil galvanometer is directly proportional to the current in the galvanometer. That principle is used in moving coil galvanometer, right? Okay, now seeing 19th question. What is the nature of the force between two parallel conductors carrying current in the same direction means it is attractive force. So the option A is the right answer. Mutual force, repulsive force, all the above. So the option A is the right answer. What is the nature of the force between two parallel conductors carrying in the same direction, carrying current in the same direction? Attractive force. Opposite direction, repulsive force. If the question is there, means we'll discuss that one, right? Okay, well, it is there, right? Same similar question is there. What is the nature of the force between two parallel conductors carrying current in the opposite direction? Opposite direction means no doubt it is repulsive force, right? Okay, now see, students, this is all about the MCQs. Means in this video only we are expected questions we are discussing. Means at least 90, no, not 90, at least 80 to 90% these questions will be there, I think. If it is arises these questions means we are a lucky persons. Otherwise, no, we have gaining some knowledge. Okay, thank you for watching this video. We'll see on the next MCQs chapters. Thank you. Bye bye.